Alright, we're working on problem number 26. I actually got started on this one a little earlier and then got interrupted, so I'm just going to jump right in. We've got two triangles, one of side 6, 8, and 10, okay, and the other of length. We're only told the length of one side, and that's the hypotenuse, and it's of length 18. We're told these two triangles are similar, okay, similar triangles. We've got a 3, 4, 5 triangle on the one, and we know the other must also be a 3, 4, 5 triangle. So, and we're asked for the ratio of the areas. So the area of a triangle equals 1/2 base times height. And so triangle 1, or triangle ABC, I think as it's labeled, would be 1/2 6 times 8, or 3 times 8, so 24 square units. In order to determine the area of the second triangle, we have to figure out what these are. So we know that's 3x and 4x. Okay. Oop. It was 18 squared, or actually, that's more complicated than it needs to be. We're just going to delete that. There we go. So, oh, here's the ratio of all of these sides must be the same. So 18 over 10 is the ratio. So we know that let's call this side A and this side B. So we can set up these ratios. A over 6 equals 18 over 10. Right, because A would be 1.8. Yep. So A in this case would be A equals 18 over 10 times 6 equals 3, 5, there we go, 36, 54, yep. So that would be 54/5 for side A. Right, so 6 times 1.8. And B over 8 equals 18 over 10. So B would be equal to 18 over 10 times 8, right? 5, 4. So 18 times 4 would be 54 plus 18, right? Because we just did that problem of 3 times 8. So that would be equal to 72 over 5. So this would be 72 over 5. And so we're told triangle area of triangle 2 equals 1/2 54/5 times 72/5. And that actually, this is getting pretty complicated at this point. Oh, there we go. So it's going to be a little more complicated to do the math on this than what we'd like, and so we're just looking for the oh, I know what we could do. It'd be nice if I could pause these videos while I work through some things in my head, but I can't. So, what we must do superimpose these. So I'll use different colors. There we go. Actually, that's not to scale. That is 10. This would almost extend the same length, just a little more. And you'll notice that twice the area, right, of this would just be this rectangle. Likewise, twice the area here would be this rectangle. And so we're asking, how are these two rectangles related when we're only given the hypotenuse? The area of those oh, okay. So let's break this down a little easier. Here we go. Area of triangle 1 equals 1/2 base times height, and so we'll actually call that x and y, equals 1/2 x and y. And area of triangle 2, 1/2 a times b, and we're looking for the ratio of these two. So that is equal to 1/2 x times y over 1/2 a times b, right? The 1/2s cancel out. So we've got x times y over a times b. But we just showed that a equals 1.8 times x, right? That's up here, that's what we showed. A equals 1.8 times 6. 6 equals x, and b equals 1.8 times y. So we can substitute that in up here. Actually, let's restate it. Down here, a triangle 1 over area triangle 2 equals x times y over 1.8 x times 1.8 y, right, which is equal to 1 over 1.8 squared times x over x times y over y. Okay, any number divided by itself is equal to 1, So the ratio is equal to 1 over 1.8 squared. But it's asking us to express it as a common fraction, and that fraction would be, remember we had, that's equal to divided by 1.8, 18 over 10 squared, right? Which is equal to 10 squared over 18 squared. Or, to simplify a little bit further, right, because we know we have some common factors there. 10 over 18 squared equals 2 times 5 over 2 times 9 squared equals 5 over 9 squared equals 25 over 81. So the ratio of the area of triangle ABC, the smaller, to the larger. Remember, when we're expressing this ratio, it's important to know which one is on top and which is on the bottom. So we've got 25 over 81. So that one's a little longer. The video replay is a little longer, and it actually showed that when you're thinking through a problem, it's okay to step back and say, hey, this where I've gotten to, okay, this step, all right, this step here, this is going to be hard. And if I don't have a calculator, if I had a calculator, it'd be easy. It'd be easy to do, to figure that out. But it's actually probably more instructive, okay, in terms of the ratios, okay, is figuring out, and I had to draw it out. I had to see, okay, this line here is some length of this line here. So this line, okay, is related to this line. And this line is related to that line, to that length. And if I knew the ratios, if I knew the relations between those two lines, I'd be able to figure it out. And so we're given the ratio of each of these sides, right, by saying, it's 1.8 times 1.8, or 18, 18 over 10 is the ratio of those sides, and then figuring out the ratio of the areas just becomes a matter of working out this right there.